Hello everyone. On this video we will be looking at the derivative of inverse trig functions. Okay, so before we get started, this is kind of a review from trigonometry, showing that you have your trig functions. Okay, so if you have sine of x, of course sine of x has a domain from negative infinity to infinity, but we can't use it from negative infinity to infinity because inverse functions are monotonic. Okay, they're either strictly increasing or strictly decreasing. Okay, so what we're going to do is we're just going to look at the domain from negative pi over 2 to pi over 2. Okay, which is increasing. Okay, so we find our inverse, and that domain is now the range of our inverse. Okay, same thing with cosine. From negative infinity to positive infinity, it goes on forever and ever, but it is monotonic between x equals 0 and pi. Okay, so if we find the inverse, now the range of our inverse function is formally our domain from 0 to pi. Okay, same thing with tangent. We go from negative pi over 2 to pi over 2. We find our inverse. Now our domain is now our inverse range. Okay, same thing with secant, cosecant, and cotangent. Okay, now you don't have to write this down. This is kind of a quick little reminder. But if you do want to write it down, feel free to press pause and write all of this down. But we're going to go ahead and move on to our next page, which shows us the actual derivatives of inverse trig functions. Okay, so the derivatives of inverse trig functions. Okay, so we're not going to worry about the proofs of these. I mean, if you want to, most of your textbooks have proofs, so you can find them online. They're pretty straightforward. Okay, we're just going to look at the actual derivative definition. Okay, so let's say you have the derivative of sine inverse of x. Okay, the derivative of that is 1 over the square root of 1 minus x squared. Okay, now the derivative of cosine is not that different. Well, cosine inverse. The derivative of cosine inverse of x is just negative 1 over the square root of 1 minus x squared. Alright, now what if you have, instead of an x value or just the term x, what if you have a function in there? What if you have a 3x squared plus 5x plus 4 or something like that in there? Well, that one's not too far off. Okay, so let's say if you have the derivative of sine inverse of some function of x. Oops, let me close that up. Okay, now that will equal almost the same as this one with just minor differences. Let's say 1 over the square root of 1 minus that function of x squared times the derivative of that function of x. Okay, so as you can see, that's not a big difference. Okay, and same thing if you remember your cosine inverse, then that cosine inverse of a function of x is of course just the negative 1 over the square root of 1 minus that function of x squared times the derivative of that function of x. Okay, so really, if you remember sine inverse of x, or sine inverse of a function of x, you remember all four of these because they vary slightly. Okay? Alright, now what about the derivative of tangent inverse of x? Okay, well that is actually equal to 1 over 1 plus x squared. Okay, so what about the derivative of cotangent inverse? You guessed it. The derivative of cotangent inverse of x is just a negative 1 over 1 plus x squared. Alright, so if you're looking for the derivative, if you have a function there, just like up here, it's just a slight change. Okay, so what if we're looking for the derivative of tangent inverse of some function of x? Then that is just going to equal 1 over 1 plus that function of x squared times the derivative of that function. Okay, same thing with cotangent inverse. The derivative of cotangent inverse of some function of x will equal negative 1 over 1 plus that function of x squared times the derivative of that function. And once again, if you remember tangent inverse of x, then you can remember the rest of these because they're slight changes to them. Alright, so let's look at the derivative of secant inverse of x. Okay, so that's going to equal 1 over the absolute value of x times the square root of x squared minus 1. Okay, so what about the derivative of cosecant inverse of x? You guessed it, negative 1 over the absolute value of x times the square root of x squared minus 1. Alright, so what if we are now looking for the derivative if you have a function of x? Same thing as up there. You have the derivative of secant inverse of a function of x. Then that's going to equal 1 over the absolute value of that function of x. Let me move my equal sign over a little bit. Okay, so the absolute value of that function of x times the square root of that function of x squared minus 1 times the derivative of that function of x. Alright, same thing with the derivative of cosecant inverse of x. Oh, of g of x, sorry about that. That's just going to be negative 1 over the absolute value of g of x times the square root of that function of x squared minus 1 times the derivative of that function. All right, so the best way to remember all of these is to remember your sine, your tangent, and your secant, because your cofunctions will always be just the negative of those. Okay, so if you have sine, cosine would just be the negative of sine. If you have tangent, then cotangent will just be the negative of that one. If you know secant, then cosecant is just the negative of that one. And then if you have a function instead of just the x, then really all you have the same thing, but the x's are replaced with the function of x, and then you multiply the whole thing by the derivative of that function. All right. Okay, so we're going to slide this up a little bit, because there are different ways your inverses are viewed. Okay, so sometimes you may see it as sine inverse of x, and sometimes you may see it as arcsine of x. Exact same thing, just different terminology. You may see cosine inverse of x, or you may see it as arccosine of x. Same thing, different terminology. You may see tangent inverse of x, or you can see it as arctangent of x. Same thing, different terminology. Okay. You may see cotangent inverse or cotangent. Okay. You may see secant inverse or arcsecant. You may see cosecant inverse, or you may see arccosecant. Okay, each one of those means the exact same thing. This is the same as that. This is the same as that. So you may see the derivative of arccosecant. It's the same formula. Okay, just different terminology. All right, so if you are still writing, feel free to press pause, but we're going to go ahead and jump into our examples. All right, so let's say, for example, let's say if our function of x is equal to x to the 9th power arccotangent of x, we want to find the derivative of x. All right, so this one, I'm just going to rewrite it. X to the 9th power arccotangent of x. You see here, you don't have just arccotangent. You have two different x functions multiplied to each other, where this is your first one and this is your second. Okay, so here we have to use the product rule. Okay, so that means to find your derivative, that's going to equal your first times the derivative of your secant plus your secant times the derivative of your first. Okay, so we have x to the ninth. The derivative of arccotangent of x, remember, is negative 1 over 1 plus x squared plus arccotangent times the derivative of x to the ninth power is 9x to the eighth power. Okay, so our derivative just becomes, you have x to the ninth negative, you can just make that negative x to the ninth power over 1 plus x squared plus, I'll just move that up to the front and make that 9x to the eighth power arccotangent of x. Okay, so that's your derivative. Alright, so we still have room on this page, so let's just move this up and do our next example. Let's say if we want to find our derivative for h of x is equal to arctangent of x to the fifth power. Alright, so we see here we don't have just x, so I'm not going to write up there, I'm just going to rewrite h of x equals arctangent of x to the fifth power. Okay, so we don't have just x, we have a function of x that's different than just x, so we have x to the fifth power. So let me clean up that 5. That was bugging me. Here we go. Okay, so we have x to the fifth power. Since that's our g of x, okay, so g of x equals x to the fifth power. So that means your g prime of x is equal to 5x to the fourth power. Okay, so to find our derivative for arctangent of a function of x, remember that's equal to 1 over 1 plus that function of x squared times the derivative of that function. Okay, so we already have our function of x and that derivative, so we just really plug it in. We have 1 over 1 plus x to the fifth power squared times, and I'll just use the parentheses, g prime of x, which is 5x to the fourth power. Okay, so really just simplifying that, just move that up top, so you have 5x to the fourth power over 1 plus x to the 10th power. And just to kind of make sure we know that the derivative of arctangent g of x, we know that's equal to 1 over 1 plus our g of x squared times g prime of x. Okay, so just in case you say, okay, where did you get that formula from? I'll just make that little side note. Alright, so as you can see, it's pretty straightforward once you know the formula. It's your basic plug and chug. Alright, so if you are still writing, feel free to press pause, but we're going to go ahead and move on to our next example. Okay, so let's say for this example, we wanted to determine r prime of x if r of x is equal to arc cosine of x to the 10th power. Alright, so what I want you to do is press pause, and before you do that, before you press pause, for this one, just a quick hint, you want to use the chain rule. Okay, that's my hint. Okay, so go ahead and press pause and try to work this one out on your own. Alright, so I'm assuming you've pressed pause and you've worked this one out. So let's go ahead and verify your answer. Okay. So you want to remember that the derivative of arc cosine of x is equal to -1 over the square root of 1 minus x squared. Okay, so find the derivative using the chain rule. The derivative is equal to, we find the derivative of this whole thing, so we bring down our 10 times the arc cosine of x to the 10 minus 1 times the derivative of what's inside. Alright, so that means, slide this up a little bit, our derivative is equal to 10 times the arc cosine of x to the 9th power times the derivative of arc cosine of x is just -1 over the square root of 1 minus x squared. Okay, so that means our derivative is equal to, and I'll just go ahead and simplify that. So you have 10 and -1, so that's -10, and I'll put the parentheses, arc cosine of x to the 9th power all over the square root of 1 minus x squared. And that's your answer. Okay, so as you can see, if you have a pretty good grasp of the formulas, it's pretty cut and dry. It's pretty straightforward. Just a little bit of practice and I think you'll get it. Alright, hopefully this made sense, and I'll see you on the next video.